Hello friends, welcome to the next session. Now the third problem over here is L is equal to AB whole raised to n, C raised to n greater than equal to 1. So let's get started with the problem. Now friends, again before starting with the problem, I will always recommend you, rather than always telling you that you pause the video, think about the logic, it is by default assumed that you should pause the video, think about the logic, what can be done, and confirm your logic with mine. So if you observe this particular problem, it says I'm talking of AB whole raised to n, C raised to n. Don't you think this particular thing, AB whole raised to n, C raised to n, if I say substitute this entire thing by x, so that will be x raised to n, and if I say substitute C by y, that will be y raised to n. So don't you think this problem is as good as the first problem that we solved, A raised to n, B raised to n? Yes. So the problem is ditto the same. The only thing is I have AB whole raised to n and C raised to n. Now, before we solve the problem, we should understand the state diagram. And before we draw the state diagram, we have to understand the logic. So the logic over here is very clear. I simply say over here that for each AB, I say please push one X on the stack. And I say for each C, please pop one X from the stack, right? So now this thing is very clear. Let us consider an example. So maybe if I have a string for n is equal to 2, that is going to have AB, AB, CC, right? So if I have a stack in front of me with the bottom as R, I receive a I am not going to push anything on the stack. Okay, now understand the problem over here. When I receive a I'm not going to push anything on the stack. But how will the machine understand that nothing has to be done? The machine only interprets everything in terms of states, right? So we are going to somehow think of a logic where the machine has received a and it is not going to touch on the stack, and this operation should be remembered by the machine, right? So now what I say, initially I'm assuming I am in state q0, the machine is receiving a input a. So I say once it receives an input symbol a, the stack top is R, you don't touch that, okay? But simply change the state so that you know that on receiving a I have changed the state, but I am not touching this particular stack. Now when you receive a B, as per the logic I have received entire AB. Now I say perform the push operation. Therefore I say when I receive a B, please come back to my state and push a X above the R. So this cycle q0 q1 q0 q1 q0 q1 toggling is going to work for each and every occurrences of AB, right? Then let's say once again I receive a. When I receive this particular A, my Q0 will be receiving a, not touching anything on the stack and going to Q1. And when in Q1 I receive a B, that signifies, when in Q1 I receive a B, that signifies that previous symbol is A, right? So when in Q1 I receive a B, I say go to state Q0 and push one X on the particular stack, right? Going ahead. Now when I receive a input symbol C, this is for the first time I'm receiving a C, so we know that we require a state transition. Now the thing is, where are we going to have the state transition? Q0 to Q1 is already done, and I cannot use Q1 again because Q1 is holding a state where it assumes, it is sure that previous symbol was A, and now I am allowed to get only a single B. So there is no chance that I'll be touching Q1 now. So what will we be doing is, from state Q0, if you are receiving an input symbol C, give a transition to a totally new state Q2 and say perform a pop operation. Since this is the first of operation, we are having a state change. So my X is removed, I am in state Q2, and in state Q2 when you receive any number of C's after that, keep on performing the pop operation, and finally you will be having a epsilon at the end and r at the bottom of the stack. If that is the scenario, then please go to the final state and conclude that this language belongs to ab whole raised to n, c raised to n. So now one thing is clear. This is how my transition diagram is going to look like. I'll be having a toggling state q0 to q1, q1 to q0 for one push operation, and q2 is going to be exactly same as that of the previous problems. So with this in mind, let's go to the implementation function. So friends, the input that we have over here, I'm considering maybe this time for n equal to 3. So I have AB, 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 C, 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 and over here, starting with it, I'm in state Q0. This is going to be the stack that we are going to consider. Bottom of the stack is my R. Going down, I say Q0 on receiving a input symbol A. When the stack top is R, I'm not going to do anything. So I'm not going to touch the stack, but to keep a track of it, I'm going to have a state change, and stack is not going to be touched. So I'm going to represent it by Q1 comma R. Now I'm in state Q1. So in state Q1, I receive a input symbol B and the stack top is also R. This signifies that now I am allowed to perform a push operation because I have already received a A previously and this B is after that A. So I say go back to my original state Q0 and push one X above that R, and now this operation will be reflected on the stack, right? So now this entire thing is my first AB, right? Going ahead. Now I am in state Q0. I receive a input symbol A. My stack top is currently X. Since it is A, I am not going to touch the stack, so I simply change the state, and since we are not touching the stack, I'll be showing only the latest push operation, that is X. Going ahead, I am in state Q1, input symbol is B, the stack top is X. Now I say go back to state Q0 and perform a push operation above the current X, and this operation will be performed over here, and this entire thing will execute for all of my remaining ABs. So precisely for this AB, my 1x will be pushed. For this AB, another x will be pushed, right? Let's go ahead. After all this push operation, a moment will come when I am in state Q0, input received is C, and the stack top is X, and for the first time when I receive a C, I know that I have to perform a pop operation. Therefore I change the state to Q2 as we discussed in the previous slide, and I say simply epsilon, and that X goes away. This is my first C. Going ahead, I am in state Q2, input symbol is C, stack top is X. Since prop operation was already performed, so we do not have to have a state change now. So I say Q2 comma epsilon, that pops my second X. Similarly, when I receive the third C, my last transition is going to pop my third X, and therefore I say this is going to be the operation for remaining C's. Going down, lastly, after this, when I receive a epsilon, I'll be in state Q2. Input will be epsilon, and the top of the stack will be R. And here we conclude that go to QF and do not change anything on the stack, that remains, and this we called as the last step, right? So this completes my transition function. Now let's solve an example and see whether the things are working fine. So friends, the example that we are considering right now, Q0 comma maybe A B C comma R. Labeling the rules 1, 2, 3, 4, 5, 6, 7. Okay. Coming down, Q0 on A when the stack top is R. Using rule 1, I go to Q1. I have B, AB, C, comma, nothing R over here. Going ahead, Q1 on B when the stack top is R. Using rule 2, I say go back to Q0. I have AB, 3 C's and a XR on the stack. Going ahead, I am in state Q0 on receiving a when the stack top is X. Rule 3, it says go to state Q1. I have B, C followed by XR on the stack. I'm not doing anything. Then I have Q1 on B when the stack top is X. Using rule 4, go back to Q0. I have AB followed by 3 C's and X pushed above XR. Going further ahead, I am in state Q0. I receive a when the stack top is X. Go to state Q1. Using rule 3, I have B, C and XR. No operation on the stack. Further ahead, Q1 on B when the stack top is X. Go back to Q0. You have 3 C's with you and 1 X will be pushed above the XXR. Further part, let me write it over here. So now I have Q0 on C when the stack top is X. For the first time I encounter a C, I have to go for a pop operation and a state change to a totally new state, Q2, using my rule number 5 that takes me to state Q2. I have 2 C's with me, and since 1 X is popped, I have XXR on the stack. Going ahead, Q2 on C when the stack top is X, keep on performing the pop operation. Therefore, I have the same state Q2 C XR. Further, Q2 on C when the stack top is X, keep on performing the same operation Q2 comma epsilon comma R, and that finally takes me to QF comma R using my last rule number 7, and therefore I say this input will be accepted by my push down automata. With this, we complete this problem, friends. See you in the next session. Thank you.